it's me again, Shiomi. Previously, we talked about adding dissimilar fractions or fractions that have different denominators. But what if we start seeing this kind of equation? There are fractions that are dissimilar, and then there are whole numbers. How do we add them? I'll tell you what. Why don't I give you a simple problem that would involve adding fractions similar to what you just saw? Then, let's solve it together. Okay? Here we go! June is making sweet tamarind candies in order to help with his family's income. He learned how to make different kinds of candies through his mother. Today, he is making sweet tamarind candies. On the kitchen table, he had all the ingredients he needs. He has 2 cups of mashed camote, 3/5 cup of ripe sampaloc, 3 cups of brown sugar, and 1/4 cup of water. He mixed all the ingredients in one big bowl. Soon, his mother came in and asked, "I see that you are making sweet tamarind candies. Tell me, what is the total amount of mixture you put in that big bowl?" June did not know, and so he got a pencil and paper to find out. He wrote down the amount of each ingredient he put into the bowl. 2 cups of mashed camote, 3/5 cup of ripe sampaloc, 3 cups of brown sugar, and 1/4 cup of water. Do you notice anything? We are dealing with dissimilar fractions, 3/5 and 1/4, and whole numbers 2 and 3. Let's help June find the answer to his mother's question. June added the dissimilar fractions first, but before he could do that, he had to look for the least common denominator or LCD of their denominators. He wrote the first denominator, which is 5. The multiples of 5 are 5, 10, 15, 20, 25, 30, and so on. Then the second denominator, 4. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28. Looking at these 2 sets of numbers, we can see that 20 is the least common denominator of 5 and 4. So June wrote down 20 as a denominator for both fractions. To do this for the first fraction, he divided 20 by the original denominator, 5, then multiplied this by the numerator, 3. He then got 12 as a new numerator. He now has 12 20ths as his first fraction. He did the same for the second fraction. 20 divided by 4 times 1 is equal to 5. 5 now becomes the new numerator, and with 20 as a denominator, his second fraction now becomes 5 20ths. He can now add the fractions 12 20ths plus 5 20ths. This gave him 17 20ths. Next, he added the whole numbers in his original equation. 2 plus 3 equals 5. Adding the sum of the whole numbers with the sum of the fractions he got earlier, the total amount of mixture in June's bowl is therefore 5 and 17 20ths cups. "Very good," said his mother. So, did you find that easy? Were you able to follow June as he computed for the total amount of mixture he had for his candies? Why don't you try to solve the first equation we had a while ago? Remember, practice makes perfect. Good luck!